Hello, Miss Walsh here. So today we are going to be working backwards in a sense that we will be given a graph and we are going to have to determine the equation of that graph. So the first step is to always decide on what the parent function is. And here actually we are already given the equation that's already set up for us, but that's not necessarily so, but you know your parent functions and you can go from there. Okay, so let's start with something that we know about this graph. We know that it has a vertex of 2, 1, and we know it's a quadratic. If they didn't tell us it was a quadratic, no problem, we would know that anyway. So we're going to substitute in the vertex. So we have x minus 2, and then we have plus 1. Okay, so you have three unknowns, x, a, and y. And what you want to do is you want to solve for a. If you take any point, that will give you an x and a y already. So why don't we take something that we know? We know the y-intercept, right? So we can see that the y-intercept is 0, -5. So, and that is our x and y. Let's substitute it in. So we have -5 and we have 0. And as you see, we've now substituted for 4 out of 5 things, which allows us to solve for the fifth one. Okay, a little bit of algebra here. So we're going to start with taking the 1 to the other side. And that's going to be -6. And then this is going to be -2 squared, which is 4. So this is 4a, and this is -6. Dividing both sides by 4, we end up with either -1.5, or you can do -3 over 2. A little sanity check. It's good news that this is a negative because our parabola is looking down. Okay, so let's just write the final equation down, leaving the x and y an unknown, because then we can substitute any x. And we're done. Let's move right along to the second one, and hopefully by now you can tell that this is a rational function, right? And you remember that rational functions, they have the they have the asymptotes at the axes. Okay, so let's take a look. We can see that here our vertical asymptote is at 1. So what that means is that our equation has been shifted 1 to the right. So we're going to account for that by substituting in this, right? It's inside and it's a -1, so 1 to the right. And we can also see that from, instead of at 0, it's also been shifted up 1. So we're going to put 1 here like this. Now we're going to do the same step, and we're going to identify a point, and sometimes you'll have more than one point, and you can just take whichever one you want. I'm going to take the x-intercept here, but you can see that the y-intercept is available as well. And the x-intercept is -1 and 0. So we're going to substitute 0 in here, and we're going to substitute -1 in here. And now it's just down to the algebra. Okay, so the a is still there, and then this is +1. Let's go down here. And so we have 0 is equal to -2 plus 1. Hopefully you can see to solve this, we're going to take 1 off each side. So this is now going to be -1 is equal to a over -2. And last step, we're just going to multiply both sides by -2. for resulting a of positive 2. If it was a negative 2, this arm would have been reflected here and this arm would have been reflected here. So the fact that it looks like we're by now used to it is also a good sign, okay? Let's just write the final equation. So 2 and x minus 1 plus 1. This, by the way, is a stretch of 2. So you can see, remember this 1 up, 1 over? It's not here. It's actually would have been 1 and 2 up. Yeah, so it's been stretched vertically. Okay, so just pick your parent function, substitute in what you know from transformations, use a point, and solve for the last unknown. So looking at this, hopefully you can recognize this to be a radical parent function, and you can go from there. Bye.